Even Darwin, contrary to popular belief, was originally not a biologist. Or at least he didn't think of himself as one when he set out on the voyage of the Beagle. I, a geologist, have ill-defined notion of land covered with ocean, former animals, slow force cracking surface, he wrote in his notebook. Nor did things change very much in that regard a century later, when modern biology was well on its way and molecular genetics was still a territory of uncharted wonders. Then again, physicists were among the pioneers. And an encore is happening these days as the mind is becoming the new frontier. Indeed, the brain-mind problem, a subject that for centuries had been lying uneasily at the border of science and philosophy, may be the natural meeting ground between biologists and physicists. Some years ago, a group of students and colleagues of mine at Columbia University staged a mock biophysics symposium on my birthday. The symposium was an elaborate spoof on the vagaries of biophysics and the crownings of its practitioners. It was great fun, though much of it I've forgotten. But not the refrain of one of the ditties, and it has been haunting me ever since. Biology is biology and physics is physics, and never the twain shall meet. If this audiobook helps to sink that refrain into oblivion, that is the best I would ask for. A thumbnail sketch of our journey. After a brief excursion into our sense of time, our journey will take us to the origin of all information in the universe, and we will see what that gossamer called information really is, and how it got to where it is. Above all, we'll see the steep price sentient beings must pay for acquiring it, and the natural limits to cognition. With that knowledge in the bag, we take a journey along the sensory information stream of the brain, the stream that nurses our cognitions. There, one by one, we will meet the neuronal entities who drive the stream, the prime movers who wrest information from the quantum and the molecular world outside, and those higher up in the brain who gradually extract meaning from the information hodgepodge in the stream, ending up with a coherent representation of the world outside. Chapter 1. Our sense of time. Time's arrow. Our awareness of time. We begin our journey with an exploration of our sense of time. This sense is a prominent feature of consciousness, and I mean here not the sensing of periodicities and rhythms, the causes of which are reasonably understood, but something far more fundamental, the sensing of time itself, the passing of time. This we feel as something intensely real, as a constant streaming, as if there were an arrow inside us pointing from the past to the future. This arrow is an integral part of our conscious experience, and more than that, a defining part of our inner selves. Yet for all its intimacy and universality, it has defied scientific explanation. Not that this is the only perverseness of consciousness, but I single it out because our sense of time appears to be the least ethereal, and with some prodding, it might give ground. It has a measurable counterpart in physics, the quantity t. Indeed, that t occupies a high place in our descriptions of the physical universe. It enters into all equations dealing with events that evolve. However, we should be forewarned that that time and the one we sense may not be the same. T is a sort of housebroken variety of time, a variety that was tamed through mathematics. Nevertheless, it still has some wild qualities, and for something that has gone so thoroughly through the ringer of mathematics, it is surprisingly human. This could hardly have been said before the revolution Einstein wrought. The t then was something that flowed uniformly and inexorably at the same universal rate, whether there was a human being there to observe it or not. It was, and I use Newton's own words, an absolute, true, and mathematical time, which, of itself and from its own nature, flows equably without relation to anything external. With a time like that, it didn't matter who measured it, as long as a good clock was used. The theory of relativity put an end to this disemboweled, machine-like time. In contemporary physics, each observer must take his or her own measure of it. Clocks, however good, do not necessarily mark the same time in the hands of different observers. Far from flowing equably, time varies, depending on the relative movement of the observer. This kind of notion is something one can warm to, though it may not have all the tints and hues of our inner time. The stream of consciousness. But first, what is this thing we call time? St. Augustine, one of the early inquirers and among the most profound, captured the zeitgeist when he wrote at the turn